need someone's hand to lead me through the night. I need for someone's arms to hold.
Hi, I'm Juha and I'm a hockey player here at USC. I will be going through some physics concepts and examples with you this semester. And remember, just like on the ice, there's no such thing as luck in physics. Just keep your head up and work hard.
Let's warm up with a following example. The setup is pretty simple. A ball hits the wall at the velocity of minus 30 meters per second, or 30 meters per second, and then bounces back at 20 meters per second. And we would like to know or calculate the impulse of the force acting on the ball and the magnitude of that force or average of that force. The first thing in momentum calculation like this, it's very important to define a positive direction. So we do it to the right. And in that case, we can proceed and calculate the momentum. And let's just evaluate the magnitude first. So it's always the final value of momentum minus the initial value, P2 minus P1. So we have m times V2 minus m times V1. So m times V2 minus V1. The mass of the ball is 0.4 kilograms. And then here comes the important part. We have to get these signs right. So V2 is going to the right, so it's positive 20 meters per second. And then minus V1, don't forget the parentheses. What is V1? V1 is going to the left, so it's minus 30. So we must have the minus 30 here. So it's one more intermediate step. So we get 0.4 kg times 50 meters per second. So the velocity of the ball is changed by 50 meters per second. Not only its magnitude changes, but also its directions. And here we get 20 kg ms, meters per second, which is the same as 20 Newton seconds for the magnitude of the impulse. And if you want to do this in a vector form, so this would be, J would then be 20 Newton seconds and to the right. So I indicating direction to the positive x direction. This calculation is almost deceivingly easy, and a lot of students get it wrong, including me when I did this first couple of times in high school. First of all, one has to define the positive direction or directions if we are in 2 dimensions and stick with that convention. Secondly, when we are calculating the impulse, it's the change in the momentum, and change is always the final value minus the initial value. If you flip them around, you'll get a wrong answer. And third, when we are plugging in the values of velocity, V2 and V1, in this case, we have to be very careful with the signs. So when the ball is moving in the positive direction, we have to have positive 20 meters per second in this case. And when it's going against the sign convention, it has to be as a negative. And then this negative is one potential place where people always trip as well, and then they get weird answers. So as long as you pay close attention to the signs, you should be okay. Then the part B, the calculation of average force. So we remember that impulse is the average force multiplied by the time that the interaction lasts. In this case, we have delta t to be 0.01 seconds. So we don't calculate the direction of force because it's always in the same direction as the impulse, and that's a good check as well. So in this case we got the impulse to be to the right, and that makes sense because the wall gives the ball a kick to the right, if you will. So we only need to evaluate the magnitude of this force, or the average value of it. In reality, the force will look something like this as a function of time, but we are taking this assumption that we have the same area covered by this box, and there we have the average force there, like this. So using that, F delta V, F average is just the magnitude of the impulse divided by the time that the interaction lasts. So we get 20 Newton seconds divided by 0.01 seconds. So that's about 2000 newtons. So the average is 2000 newtons, but the force peaks at some higher value naturally in the real interaction.
I need your love.